Okay guys, we'll be continuing on seeing some more questions on heating concepts of mixtures. Okay, so let's say a 2 gram sample of a mixture of CuCl2 and CuBr2. Two-gram mixture of CuCl2 and CuBr2 was dissolved in water and mixed with 1.8 grams of AgCl. Dissolved in water and mixed with 1.8 gram of AgCl. Okay, so after the reaction mixture of AgCl and AgBr was filtered, washed and dried, the mass was found to be 2.25 gram. Okay, so mixture of AgCl and AgBr after washing and drying, the mass of the mixture comes out to be 2.25 grams. So the question is, what mass percentage of CuBr2 was there in the original mixture? Okay, so the reaction will proceed forward as we would have something like CuBr2, which on reacting with AgCl, would produce CuCl2 plus AgBr. Just balancing the equation here. Okay, so let weight of CuBr2 be x grams. Okay, therefore according to the reaction, CuBr2 plus 2 moles of AgCl, which gives CuCl2 plus 2 moles of AgBr, would be x upon 63.5. That's the molar mass of the CuBr2 molecule or compound, plus we would have 1.8, which was the mass of AgCl that was given. Okay, minus x upon 63.5 plus 160. So I'm just calculating how much mass of AgCl is left, or let me write it down the next step only. So how much moles of AgCl would be consumed? This multiplied by 2 moles of AgCl would be consumed. Okay, so how much mass of AgCl would be left? Would be 1.8 minus 1.8 is the total mass of AgCl that was given. Okay, 1.8 minus 2 multiplied by x upon, this is the moles, and into molar mass of AgCl is 108 plus 35.5. 108 is the mass of Ag and 35.5 is the mass of Cl. So mass of AgCl left is this, and how much moles of AgBr is formed? Moles of AgBr formed is again 2x upon 63.5 plus 160. This is the mass of copper and this is the mass of Br2. Br's mass is 80, so Br2 would be 160. So mass of AgBr formed would be, this is the moles, and multiply with the molar mass of AgBr is 188. 108 plus 80 would be 188. So as per the question, we have the mass of AgCl plus AgBr that was left and washed and dried was found out to be 2.25 grams. So mass of AgCl would be, the leftover AgCl's mass was into 108 plus 35.5 plus mass of AGBR would be again 2x upon 63.5 plus 160 into 188, and this is equals to 2.25. This is the mass of AGCL and this is the mass of AGBR. Okay, so from here you can calculate the value of x. That is homework problem for you, just a simple math problem, and x would come out to be 1.13. Hence percentage of CuBr2 would be in mixture of CuBr2 and CuCl2. So the weight of the mixture was 2 grams, out of which 1.13 is of CuBr2 into 100. So the percentage would be 56.5%. This is the answer. Okay, now let's actually see another problem. So wherein you have to calculate the mass of AGCL formed. Calculate mass of AGCL formed when 95% pure 10 grams of MgCl2 reacted with excess AgNO3. Okay, so and given the yield of reaction is 90%. Okay, so according to question, mass of MgCl2 would be 95% pure of 10 grams would be 9.5 grams. Okay, and moles of MgCl2 hence would be present would be 9.5 over 95. This is the weight of MgCl2, molar mass of MgCl2. So moles would be 0.1. Okay, now we will react AgNO3 with MgCl2. So the reaction would be MgCl2 plus AgNO3 would give us 2 moles of AgCl. I am balancing the equation side by side. 2 moles of AgCl plus MgNO3 whole twice. Okay, so we have to calculate the mass of AgCl which is produced. So if 1 mole of MgCl2 is reacting, it would form 2 moles of AgCl, and if 0.1 moles of MgCl2 is reacting, it would form 0.2 moles of AgCl. But yield of the reaction is also 90%, so multiply it with 0.9. So this is the total number of moles of AgCl which is produced in the reaction. So number of moles of AgCl produced in the reaction would be 0.18. Okay, so what would be the mass of AgCl produced? This is asked in the question. This would be 0.18 into molar mass of AgCl, which is 143.5. AgCl is molar mass of Ag is 108 and molar mass of Cl is 35.5. So add this, you will get 143.5. So the answer would be this. You can calculate this value, 1.18 into 143.5. This would be the answer. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples, and we'll be seeing what happens on combustion reactions when carbon and oxygen combines together, and we'll be seeing cases on the top of that concepts. Okay, so all these things about the consumptions and or rather combustion of carbon and oxygen will take place in the next lecture. Okay, so till then, good luck and goodbye.